Yeah, okay, here we go.
Okay,
I remember.
great. So yeah, first item is the Hackfest. So we're doing a Hackfest at TU Delft in the Netherlands. They've been excited to work with us for a little while and are giving us space for an entire week at the end of January to hold a Hackfest. I've mentioned this before. It's on my blog. I've had some postings about it. So it's the last full week of January, which I believe starts on the 26th. So as I said, in Delft. The only issue, it's public, whether we're doing this. The only issue is that we are space limited, so this isn't a general call for participation. Don't expect to be able to just show up and get in. But if you do want to come, or if you hear about it and can make it for that week and are interested, just contact me through email on IRC. Somehow email mostly, and if you follow GNU Radio, you should know my email. Contact me, let me know that you're interested, and we'll try to make sure that we've got enough space for everybody that is actually interested. So we don't want to exclude anybody, but just know that we are space limited, so we can't just have anybody come at any point. But yeah, so that's the last week of January. Sounds like it should be a really nice setup for us in the university there, and many of us are going to be going basically straight from Delft that Friday down to FOSDEM, to Brussels for FOSDEM. So if you're interested in FOSDEM as well, make sure we know that, so we can probably, we'll try to just essentially schedule a train to take us from one to the other on that Friday. And so with that, I will pass it over to Martin to talk about where we are with FOSDEM.
Cool, thanks. Okay, so FOSDEM, I'm just going to repeat it all again, is a huge conference in Brussels, generally open source theme. There's a lot of open source stuff going on there, and we have our own track, and by our own I mean the free software defined radio community. It is on Sunday, which is the 1st of February. So yeah, and there's basically an entire day of talks on free software defined radio stuff, and we would still very much like your participation. I mean, that includes both just showing up and having a look at the talks. Although all of the talks will be recorded and posted online. So if you went there last year, you can actually watch all the talks, all the videos of all the talks somewhere on the internet. Use the Googles for that. But for the open slots in our agenda, so they're not all full yet. And obviously, we'd like to have a big diversity of projects coming, so not just GNU Radio, but obviously in this call, I'll be mainly addressing GNU Radio people. And anything you've built, you just want to show stuff, that is a good place to do that. So this is not an IEEE or ACM conference. There's no paper reviews. You want to show some cool stuff. Put it in the call for participations. I mean, on the website for suggesting talks. And if we have too many talks, then we'll have to pick the best. But last year I think we had exactly the right amount. We had it all full up, but we didn't have to send anyone home without presentation. Yeah. And as Tom already said, it's directly after the Hackfest in Brussels. So for all those Europeans, no excuse not to be there.
Yeah, and just to add on to that about the call for participations, as Martin said, this isn't like an IEEE peer review type situation. It's a group of mostly enthusiasts, and it's often students from around Europe that come to this. So it's a great place to get feedback on works in progress. So if you're working on a journal or a conference paper, and maybe halfway through, where you have a demo that you're trying to show off, it's a very, I found to be a very positive atmosphere to get good feedback on stuff like that. So keep this in mind as something to show off what you're, like I said, a work in progress. Even if it's not a complete full blown thing.
Yeah, absolutely. You're working on, yeah, but it can be anything really. You're just hacking on some stuff for fun, or you're actually doing it for research, like for your PhD, for example. Just show off your stuff, and you'll meet some interesting people there, I promise. Okay, that's all I have to say for FOSDEM. It's been repeated. Please come and present your stuff. Other than that, I think
and help us get the word out as well to other communities outside of GNU Radio.
Yeah, tell your university working group about it, etc., etc.
Yeah.
Okay, cool. So we have one big issue on the agenda today: digital modulations, and I think easiest if you just take it away.
Yeah, okay, so this has been a topic that's kind of been bugging me for a while now, and we've made good strides on it in various pieces, and so I've been working to try to bring all those pieces together and come up with a more coherent plan for not just digital modulation from a physical layer perspective, which we've done fairly well for a while now, but extending it to the data link layer and up so that we can have full frame and even burst packet support has been kind of a thing that we've you could always have done or for a while you could have done in GNU Radio, but it would have been, it's just not as maybe easy as it should be. So what I've been working on is started with the guided tutorials that we put together through the user experience working group, where one of them, Martin, walked us through how to build a chat application. But that chat app was just, you basically enter in a string on in a dialog box, hit enter, and it would be pushed over to a receiver. And those kind of the blocks to create the message and to receive the message were done as part of the tutorial for working with blocks and things. So that was a really good way to explore making blocks and working with messages and kind of showing the PDU message passing architecture. What I've done is I've started there and I've expanded it to go over the air, so that we can now have, put in a full modulator and receiver chain doing all the timing and frequency and phase synchronization on the packets that are going over the air, as well as having things like packet header, so including information like an access code to synchronize off of and a header length. Now, it's kind of our standard packet header that we've been doing for a while, but I wanted to take some of Martin's ideas from the OFDM world, where he's got a packet header generator and then a way to synchronize that packet at the receiver. But the format of that packet is actually based on is a class inheritance structure, so that if you wanted to, so the general default one is like an access code and then the length of the packet, like the bare minimum to be able to synchronize and understand the what packet data you're pulling in. But then maybe you want to add other data to that, something that describes what what modulation that the payload was modulated with, or some other information about. I don't know. I'm actually probably I'll put in timing, right? So I want to do some latency measurements. I can put a timestamp into the packet and then recover it at the other end. I wanted to make it easy to be able to build new versions of the packet header structure and parser, so that we understand, so we're not tying ourselves into a very limited scope of how packets are created. So that's what I've been doing. The result is actually the chat application working over the air with full forward error correction. So using our FEC API actually ties into this as well. From the community perspective, that's all going to tie back into extending our tutorial set. So the next tutorial would be, how do you do packer synchronization, and what are the downfalls in in the structure, or how do you work around some of the issues that we have, and then how do you do this over the air and make sure that you're doing the synchronization correctly over the air, and then let's look into how do we do forward error correction. So I think there'll be some really interesting stages for how to go through this. So what that's led me to is trying to understand what blocks we have in GNU Radio, because we have a ton of blocks that do, as I said, like part of this, or a lot of duplication where one block does almost the exact same as this other block except for this minor tweak. A good example of this is the correlate access code blocks. So we have a number of different ways to correlate against an access code that then produce the data after the correlation in a bunch of different ways. And it's kind of confusing why we have all these different ways and where do you actually make use of this and how do you best do this. So the plan from here is to take these ideas that I've been working on, take the structure that Martin and Matt and others worked on for the OFDM rewrite a couple years ago, and then probably work with Tim O'Shea, because this kind of falls under his functional architectures working group, to identify all the blocks that go into this structure, try to understand what the duplication or overlap in responsibilities is, figure out how to deprecate, which ones to deprecate to clean up the space, which ones can we possibly combine into a more coherent structure that actually does something more functional for this type of communications, and then come up with a plan for how to integrate this, because this is going to be, like I said, it's going to be a lot of deprecation and removal of some blocks, so we need to have a plan for that for the release schedule. Hopefully by 3.8 we can have this kind of cohesive structure. But we need this to be well planned and well understood, what we're removing, why, what we're combining and why, and what we're adding as well. So Martin and I were talking about this, and what our plan is that he and I, and probably with Tim, is going to try to come up with a document to describe this. And at that point, once we explain what we need to do and why, we'd like feedback from people who are also working with this or struggling with these concepts, or have other demands or requirements that we haven't thought of. So hopefully by the end of this process we'll understand what do we need to do to change within GNU Radio, add to it, and what kind of things we're trying to make a GNU Radio structure able to support, as far as digital modulation, and specifically packet-based and burst packet-based digital modulation. So yeah, I think that hopefully covers the full scope of what I've been trying to do and where we're trying to take this. And let's see, are there any questions from people on the call? And I know Sean, if he's in the chat room, if he's listening, I know he emailed a mailing list about this exact topic yesterday. So if he wants to throw in some questions on the chat room, we can maybe talk about some of that as well.
Yeah, can you guys hear me okay?
Yeah. Oh, you're on? I didn't realize you were on.
Yeah.
Oh, perfect. Okay.
Yeah. So yeah, I think you hit on the points that I mentioned in the email yesterday of just like I kind of know the correlate and sync block was sort of experimental, and it does like a matched filter correlation on the incoming data stream to try to pluck out what's to match a preamble that you had predefined. And I think that's great because that's really cool functionality that you guys added for getting a phase and a time estimate, and then using that stuff to kind of like seed or update the synchronizer blocks down the chain. But everything else, like the benchmark scripts and a lot of other people's applications, I think I've read somewhere that GRAIS, like a lot of the other implementations that are full implementations at this point use the old way, which is using you kind of do the match filter and then the demod, like binary slicer or whatever, to get bits out, and then you do the access code there and you just count how many bits are wrong, and and then you set what threshold it is to say yes, this is a good match or not. But I guess the thing I'm repeating myself from the email, but basically how do we kind of tie that in efficiently with this burst structure where that you're not going to have necessarily 100% duty cycle on an incoming signal. Like, it's going to be packets that could be sporadic or sparse. So like tightly integrating that with some kind of like squelch or threshold detect block would be really nice. And it should be done in a generic way so that it can be applied across all kinds of different, applications people want to do, and not just built specifically for a particular protocol.
Yeah. Yeah, no, precisely, and that's kind of part of the reason for having this design document that we're going to try to craft, which is, again, what are the stages of acquisition and synchronization that are required to happen. So, like what I'm doing actually, I will probably pull in the correlate and sync block. So, and this is kind of weird, right? Because we're doing the correlate and sync, which does the match filter off the access code. But then it passes the entire structure on, along with the tags to help the synchronization. But then down the line, once we've gotten the physical layer synchronization, we still have to do the bitwise access code correlation, because that's going to help us. Once we get to the bits of it, we need to be able to not only detect where the beginning of the frame is, but also unpack the header so we can get that information as well. So we're kind of using that as in two different stages. But then there's things like, you mentioned in your email, AGC. How do you do proper AGC on burst packet detection? And that's something that we'll have to discuss as, again, that's part of that acquisition stage. What do we need to get the initial acquisition and ramp all of our circuits up, so that the levels are correct and the timing, phase, and frequency are all taken care of as well. So yeah, so those are definitely part of it. So yeah, as we're doing this design document, that's the kind of feedback that we're gonna need from you, Sean, and others in the same situation or with the same desires, to make sure that we haven't missed anything, that we haven't just left something out because we've been, we made it too simple or something like that on our end, and forgot about some of your needs. Does that clear some of the stuff up?
Yeah, I think so.
Good. All right. But yeah, definitely we'll want to make sure that you keep an eye on that to tell us when we've forgotten something.
So this is a good place for people to bring up, suggestions and, I don't know, comments on this whole topic, if you have any.
So I think part of the issue that we're going to have to deal with is, when do we break from the streaming model into the packet-based model? And I feel like I've solved that in my own work here. This is actually on my GitHub branch. I actually just pushed the latest thing about an hour ago. So we can see that, actually the GRC files aren't there, but all the blocks are. But anyways, so I feel like I have a pretty good grasp, or I've made a pretty good structure for, when do we use PDUs and when do we break out of that in the transmitter to go streaming, and then in the receiver, when do we go back into this PDU structure. That seems to work really well for me in this model, but it's definitely going to be something that we'll want other comments on, or other design philosophies to work with. Yeah, part of the problem that I think we're having with this talk right now is these are plans. We don't have any, I'm not showing you guys my GRC graph, and we're not walking through that. That's not what this is about. So details are going to be hard to get into. Right now, I think we're just trying to give you a overview of the fact that this is a serious issue to us, that we are actually pursuing this directly right now, that hopefully we'll have a pretty good structure in place by the time we're done. But I think maybe the best thing to discuss here is how we can do this community-based feedback. Martin and I thought that just having a design document that we work through and then publish and let people criticize, kind of a request for comment type thing, should probably work. Is there any people with thoughts on how to make that system work well? So hopefully, too, if we do this, with this design process, this design document idea, that this could hopefully become a regular thing for us as we're trying to put in new stuff, influence changes, especially when we're talking about changing blocks or deprecating blocks or changing the interfaces. We want to make sure that this stuff is well publicized and published somewhere, so that when things do change, we have a reference so people can be prepared for it, and also look at the reference to understand what was changed and why.
Tom, is there already a space like on the wiki for this particular set of issues?
No, not really. Not that I can think of, at least. Martin knows the wiki pages structure better than I do. But as I said, this goes under Tim's FASP working group, the Functional Architectures working group. So we'll probably try to make a space under there eventually for it. Although we'll probably start it as a document and then maybe move it over to the wiki eventually. But no, right now there really isn't.
I think having a page on the wiki is a really good idea, and keeping it like as a live document where we continuously update stuff, and then from time to time we actually call for comments on that. I think that's the best way to go. So if I'm really interested, I can keep checking updates on the wiki, but like the general call for comments would be just at certain stages.
Okay, Martin, you have any issue with that?
No, I mean that's basically what we discussed anyway, and gives us all the flexibility we need and all the communication, the possibilities we need. So sounds good.
Okay.
I had one question before we move on. Oh yeah, sure. Sorry.
No, go ahead. It's fine.
Go ahead.
All right, Sebastian.
I was just
Sebastian.
wondering what role are gonna take the tag streams in the future architecture that we want to have?
I think that's just going to be a question. I don't know if we can fully, properly answer that right now. But that, I mentioned going between the streaming model and the PDU model, but that does also bring in where do tag stream blocks play in this.
Okay.
Now, in the model that I have, and this is kind of was started by the guided tutorials, is that we were doing tag stream blocks on the transmit side because that's actually nice to be able to tell the UHD drivers in particular in this case, how to burst that packet out.
Right.
So I use them there mostly as a way to indicate to the UHD when there's the burst. On the receive side, actually, I don't actually use tag streams. But anyways, so again, I've done it in a way that makes sense to me, and that will go into helping us structure this document. But then we'll want to have that conversation about what we're missing, or how else we could do it.
Okay.
So.
If I could, I guess just point out a couple things. So there's when we're doing bursty traffic, and if you don't want me to dive into details now, we can always delay this until you guys have that document ready or whatever. But so right now I kind of have like an awkward structure to put like a ramp up and like a bunch of padding zeros and all kinds of other stuff at the beginning and the end using, I think it's like a tag stream mux, and then I have like a vector source on the start and the end to put that stuff before and after a packet. I feel like there could be a cleaner, more efficient way to do that, and maybe even, but it still kind of makes sense to do that maybe once you transition from PDU, which is kind of like you're handling data as a payload, and then maybe adding a CRC, maybe adding a header, and then I don't know, I pump it through a PDU to tag stream block, and then do all that other stuff in the streaming domain. And I don't know if that lines up with how you've done it, Tom, but I don't know. It seems like kind of formalizing a way to do that would be a good idea.
No, that's definitely an issue that I had to work around as well, because like so I'm doing narrowband modulation, so it's it's a QPSK signal is what I've been kind of focused on. Although I can switch between QPSK and BPSK very easily in my model. Should be able to go to APSK too, keeping in that structure, that PSK structure. But anyways, part of the concern with doing it that way is that we're going from a PDU, a packet that has a structure and has a number of bits in it, bits, to modulating it with a constellation and putting it through a pulse-shaped filter. That pulse-shaped filter has a group delay, so it has some memory, which means that I actually have to throw on some added zeros onto the end. So I have my packet is the access code, header information, the payload, and then a CRC. And then I pad on some zeros long enough, as I have enough zeros on there that's the length of the filter in symbols of the pulse shaping filter to make sure that I can push it out. Because right now it was getting stuck in that filter because there's nothing to actually push it through. Unless I padded on some zeros. So that's one problem. The other problem that you brought up is the ramp up, is to to make sure that the AGCs and the all the synchronization loops are activated basically by the time actual structured data gets there.
Well, that and also to reduce spurious emissions.
Oh, sure, right, yeah, sure. So that you're not just turning on and off very quickly, which. In my case, the pulse-shaped filter helps with, because that does have a ramp up and ramp down on its own. But yeah, no, definitely, those are. And the way, like I said, the way that I solved it was I actually have an asynchronous PDU-based block that adds the header information to it, and it allows me to tell how many zeros of padding I want to put at the end. It works, but I am similarly not really happy with that as a solution, even though or maybe we have the tag stream block, can be respected along the way to actually, push things through these filters or, anything where it might get stuck because it's expecting it to be a certain length and the filter actually increases that a little bit.
Do you also pad for like extra padding so that going over the USERP that you clear out all their filters and things like that?
No, because I think that's what the tag stream, Martin, maybe correct me if I'm wrong on that, but by telling the UHD transmit, the UHD sync, the tag to look for the burst, and that including the length seems to be okay in my case.
No, I think Sean has a point. There are some filters in there that,
Okay, so that tag stream is not being used in that sense. Okay.
But what it does is basically what it does, it avoids you getting underrun warnings, which aren't actually true. It just knows that there's not stuff happening, but it doesn't actually reset the DSP chain.
Okay.
And I don't think it should, because you never know when the next symbol or what the relation is. So I don't think the USERP should make that decision.
Okay.
I know, Sean, you've been asking like how many zeros do we actually need, and that is that is a difficult question. It depends on a lot of things.
Right. I mean, it depends on, but it's a deterministic thing. I think based on the length of the filters, the amount of decimation you're applying, or interpolation on transmit side in the user. I don't know, but I feel like those things are deterministic and could be
you can
modeled somewhere. Or
you can just look at the Verilog for that. That'll.
Right.
But yeah, that's a good point. Is it'd be nice to know that and not
have it documented.
Not have everybody have to look at the Verilog to come up with the same answer.
Yeah.
Whereas, like in the pulse shape filter, we actually define the pulse shape filter as to hold some number of symbols that we're transmitting. So that's an easy thing to go. Okay, well we have 7 symbols in the filter, so we need to make sure that we can push out all 7 of those symbols.
I mean, I think what we can take away from this discussion is that, in general, when we're building packets, then we need all kinds of blocks, and we need a good way to put them together. And I mean, the header being the most obvious, but also anything before the header, so ramp up stuff, and anything after the actual symbol packet for ramp down. I mean, we could also have something
all in one block too. I mean, well, maybe not one block, but I mean, like, you could kill the 2 birds with 1 stone for both the pulse shaping filter within GNU Radio and any hardware.
You just have to like define. I don't know. Like, should be an easy way to when you build a packet, it should be easy and obvious to do all of these things, and you shouldn't have different mechanisms for the individual items, because adding a ramp up sequence should be exactly the same as adding a header and so on and so on.
Yeah.
Right.
Yeah, that sounds good.
On the receive side, though, you said, Tom, you don't use tag streams. So you don't use a tag to mark, this is what I think is the beginning of the packet. Or do you have like a block that basically just figures out what is actually the very first bit of the or the actual data, and then you demod from there and like push it as a PDU?
That was one of the the latter, and that was one of the changes that I made. Let me actually go ahead and do this. I'm actually going to share my GRC screen so you can just see it real fast. And somebody stop me if I'm going too long on this. But it's probably useful to just have it up here. Where's my? All right, is that showing up for everybody? So this is like a loopback model that I've created. So can people see that?
It's a bit small on my screen, but I think that's my laptop.
Okay, yeah, and there's no way to till we get to Sebastian's Qt version. So this one does the full loopback. So it's got so it comes in, pulls in the payload, puts a CRC onto it, FEC encodes the whole thing, puts it through this packet header generator where I've given it an access code and told it how many symbols to pad. Then I convert it into the tag stream block, modulate it, throw it through a channel model, and then on the receive side, we can basically ignore the tags at this point because they wouldn't go over the air at that point. So then I do basic the timing synchronization, frequency and phase synchronization, and coming from from complex samples to 2 bits per symbol QPSK. Do the differential decoding, unpack it. Now this is the weird thing. This is something that I need to that we're going to fix in the future. But what happens here is this asynchronous packet block can either pull in hard bits or soft bits, and right now it's pulling in soft bits because that's what all the FEC decoders are expecting. So I have actually both support for. So if it's hard bits in, then I'll just go from here, break that chain, and do it that way. But so now this pulls in streaming samples of bits, finds the access code, uses that to trigger everything else, uses this payload formatter concept that I stole from Martin's OFDM idea. So this formatter tells me how the packet header is created, takes the access code from that. In this case, the default formatter just looks for the length in the header, so it knows the length of the packet, packages that up into a PDU. So the PDU payload itself is now packed bytes of the actual payload with the access code in the header stripped, and then I can go and I can do the CRC check and then into our full chat receiver. So does that kind of clear up kind of how I'm doing it? So instead of doing any tag stream stuff, this goes straight from the streaming data into the PDU world, and I'm perfectly willing to relook at how we do some of this stuff.
Is that GRC file on the branch you posted today on the mailing list?
No, it's not. So this was basically a modified version from our the guided tutorials that we have. So it started off with your chat app, and then started, and there's various stages of this, and eventually they will go probably into the tutorial section. In the meantime, I'll probably just publish them somewhere else, but it's not part of the actual branch now.
Yeah, it would be interesting to have a actual play around with that GRC flow graph.
Sure, yeah, we can get that out there. And yeah, it was nice because now I can, using our FEC API, I can go in here and switch from our convolutional code to the repetition code to the dummy code. I would have loved to be able to do more FECs once we get them defined and put into our system.
So Tom, I guess you're not doing any FEC on the header, is that correct?
That's right, yeah. So because we need to detect the beginning of the payload, and so the header is sent in the quote in the clear. And the way that I
do some kind of like Hamming or some small like Reed Solomon or something on the header.
But again, most of an FEC decoder has to know where to begin looking. So our FEC API, would have to come in and know that, oh well, here's the beginning. So it'd have to already know how to unpack or how to detect that access code with its own encoding on it. So my thought on how to do that would be, instead of defining the default header, you would inherit from this formatter and have a formatter that does BCH or Hamming, or like Bluetooth does a repetition code on its header. So you would define that as part of the formatter, and then the sync itself, or this packet sync block, would also know how to detect the access code that's under this kind of structure.
I think that's a good way to do it. Although I wonder, is it still possible to pull in? I mean, and I know that like some of the FEC API stuff still needs rounding out with these additional types of FEC, but it would. I mean, I would hope that it would be. It seems like it would be natural to be able to at least access those FEC functions and bring them in as tools inside your,
That's an excellent idea. Yeah. And again,
it should
like
be
I said,
done a different way, right? Or
No, I agree, because we should be able to define a BCH code once in the FEC world and be able to use that elsewhere in whatever format we need. Yeah, no, that's something we should definitely keep in mind. And honestly, like I said, I know even in our case of the default header, it's not just the payload length; it's actually the payload length repeated twice. So that you have to check to make sure that the payload, that the two sets of 16 bits match before you can actually demod it. So that's a little bit of a check before you can even attempt to decode it. And it's a bit of a protection, right? Because if you have a bit error in the packet length, and you try to and it tells you that you have to demod 1 million bits as opposed to 15, that's a bad thing. So that basic check is already a little bit of coding. But as I said, I know at least Bluetooth 1 version 1 did a 3x repetition on its header, so that you could have just that basic protection there, which is one of the motivating factors for why I defined a repetition code as one of the early FEC API codes. A, because I know it's actually used, but B, because it's also really simple to do. But that would be a motivating case to make sure that if we defined a packet header formatter, that it could actually just pull in the repetition code that we've already defined that AP through the API. That'd be a really good thing to do.
Yeah, I agree.
Cool. Okay, I think we should probably stop there. So we got like 15 minutes left to the call, unless there are any more general questions about this process that we've been talking about. And Sean, if you have any more questions on this, I'll post the GRC somewhere, and we can do it over IRC or email on the mailing list.
That'd be really cool. Thanks.
Cool.
Yeah, I think we should move on to. I mean, this is basically where the whole discussion starts. This is not the end of it.
Yeah, exactly.
Plenty of opportunity to discuss this. Okay, so I'll go straight on to the next item. The release. We had a bit of a discussion before the actual call started. Jonathan, maybe you can just repeat that.
Sure. We don't really have anything major going on. We have a lot of smaller, interesting new features. So Tom and I have been trying to figure out if it's worth capping off the year with 3.7.6 full release, or whether we just come out with a bug fix 3.7.5.2, because there's a few more important ones. I think we're leaning right now toward 3.7.6 sometime before Christmas, just to be able to start out the new year on a fresh track. But there's nothing else really pushing for us to do either one of those.
Yeah, and I think I'm in support of having a end the year on a release. Which start so we'll have essentially one more call, which will be right at the end of December before the new year, and depending on when that falls, we may or may not have the release out before that call. So I guess take this as if you have things that you are working on that you would like to see in a 3.7.6 release, or even patches that you want to see in a 3.7.5.2, anything that goes on our main branch, start thinking about getting them in now, or telling us that you've got them coming.
So the 3.7.6 would be from the current master, right?
Yes.
Right. Now, on the other hand, I am going to be making a interim spin of the live DVD image based on the current master, and so a lot of updates from the third-party software that's installed on that. So that should be coming out this weekend, or maybe even before. I've got it ready to go. I'm just doing a bunch of testing on it.
Okay. Let's talk about.
Yeah, you keep getting Martin. You keep getting muted.
Oh, what? Okay.
Yeah.
Oh, I know, because I'm typing at the same time.
Yeah.
So this is not easy. Trying to populate the chat at the meatbot and talk at the same time. Okay, let's talk about the working groups now. I'm just gonna call them up in the order they're on my screen. I don't know if it's the same on yours, so I'm just gonna start with Doug. He's leftmost. So Doug, anything on the accelerator side going on?
So we had a call last month, and I have not yet scheduled the next one. Last month was basically working out which of the outstanding tasks, mainly on the custom buffer stuff that people wanted to tackle and who was going to have free time when. So there's not an awful lot to report there. There is some progress, but it's mainly people need some free time to actually work on these things. So I am currently planning to have another call probably in between Thanksgiving and Christmas, but I haven't actually figured out what a good time for me is and when I should ask other people for input on scheduling it. So yeah, not a great deal of progress, but we did have a pretty good call last month in that.
And that call has its own wiki page, right? So if people want to know what...
Oh yeah, although I think thinking back on it, I don't think I ever updated it with any notes or anything. So there is a page, but it doesn't really say much.
Oh, okay. So are you planning to do that, or is it just... I mean, just asking, though.
I probably should go back and update it so that it at least reflects something about what was discussed.
Yeah, I think we should have a record in there.
Okay, so the main effort, just to sort of recap, is the custom buffer stuff, I guess.
Yeah.
Anything else, Doug?
I don't think I have any other major announcements.
Okay.
But yeah, I'll plan on sending out an email sometime soon about scheduling the next call.
Okay. Nathan?
Yeah, so we had a Volk call. Can you hear me okay?
Yeah.
All right. We had a Volk call on Monday, and we basically discussed, so the first thing, so we have this link that I'm going to keep on pushing for the coverage table. So there's recently been a bunch of Neon kernels added. That will sort of continue, but taper off now. Pretty much everything that's used in GNU Radio has a Neon kernel. There's a couple of outliers. A couple of them just can't be done because there's no 64-bit float, things like that. But I just want to keep on publishing that link so that, in the hope that someone will say, I need this to be faster, and realize that they can actually do it. The big thing is breaking the Volk out into its own project. We spent a lot of time on that in the call. We have an experimental Git submodule on my GitHub accounts, and it looks like we've made some pretty good progress on just all the build system, making everything reference Volk instead of GNU Radio in the submodule. I'm not sure exactly when that will officially happen, but it's in the pipeline of things that are currently going on.
Excuse me. Yeah, but we've made a lot more progress on. We've talked about this topic for a while, but we've actually seem to have a plan now and are starting to enact it and getting familiar with how we're going to do this and keep it inside of GNU Radio being tracked properly. So yeah, it's good motion on it.
Cool. Phil, any embedded stuff?
Nothing dramatic. I am working on just making it easier for people to fiddle with embedded stuff. You can hear me okay, right?
Yes.
Yep.
And I put up some test images for people to try to see if it helps them get their Zinc-based boards going faster. And when we get that done, we'll probably go and look at the wiki page and try and get people started in a more direct fashion.
And in the meantime, I did make some edits to the wiki page based on our discussion back at the GRCon.
Yeah.
So I tried to I didn't change too much of the text, but I tried to rearrange it so that it was more obvious what we expect the users, like most of the users who want to do embedded stuff. I tried to get that model a little bit more prominent. So that helps.
I need to get some stuff onto some more stable branches, and when I do, I'll put up a set of coherent images and SDKs, and then we'll start looking at the documentation stuff, and hopefully we lower the barrier to entry quite a bit.
Yeah.
Cool. Sebastian.
Hi. So we had our call 2 days ago. Talked a lot about GOC-QT, which is basically the main and only focus of the working group right now. We kind of finally got organized and moved the various parts of the code people have been writing into one branch, and now working on that, which is in the working group repository on GitHub. Other than that, I think I've pushed a couple of minor bug fixes, and I have a rewrite of the generator of GOC, which actually produces the Python code that's to be executed. And this rewrite contains some restructuring that allows arbitrary placements of message and stream ports on hierarchical blocks, which was up until now kind of buggy and not really reliable for the users. So this should work pretty stable now, I hope. It's not in the mainline yet, but hopefully soon. So this is kind of the only real change since the last call.
Cool. So Tim isn't on the call, but we've talked about digital modulations basically for most of the time anyway. I think that's also covered. Yeah, I think we're good for this month. Nearly 8 o'clock anyway.
Well, what about your working group, Martin?
Oh, right. Yeah, I keep forgetting that because it's not really a working group.
Well, we got the tutorials, and we did have a discussion recently about that, and that's probably the news.
So the tutorials, yeah, as you said, we've been working on them all the time, and we're kind of at the closing stage now. We're sort of, I think, we're probably going to take them out of beta very soon. Just some minor issues that we want to fix, and yeah, and apart from that, there's nothing really much going on there. So.
I would like to bring up, though, that there was talk about trying to get into Stack Overflow, a little bit better presence. So if we can get back in touch with Samantha and you to see what we can do about pushing that.
That is correct. Okay, but other than that, I think we can wrap it up.
Yep.
Okay, guys, thanks for tuning in. Yeah.
Yep.
Next call,
Thanks, everyone.
there'll be a call. Wait a minute. Does
Yeah.
the next date crash with some Christmas or something? I don't think so, right?
No, it's the week before Christmas, so it's December 18th. It looks like to me.
Okay. Yeah, then we'll definitely have that call. I'll post the details and yeah. Okay. See you then, guys. Bye.
Thanks. Bye.